All right, welcome back. So we're going to do just a couple examples of rates of change, and you'll see that they're really just the same thing you've been doing all along, derivatives and average velocity. All right, so first example. Suppose our function a is the area of a circle of radius r, so pi r squared. Often people just write a, but secretly they really mean a of r. Okay, it's a function of r. And you can ask, what is the rate of change or the average rate of change of this function? So let's do the average one. So the average rate of change of a over the interval 1 to 2 is, so remember the shorthand notation was just change in a over change in r, longhand a at 2 minus a at 1 all over 2 minus 1. So this is pi times 2 squared minus pi times 1 squared. 2 minus 1 is just 1. So we end up with 4 pi minus pi for a total of 3 pi. So that's the average rate of change. You can also ask for the instantaneous rate of change. That's a little easier because it'll just be a derivative. So here we go. The rate of change of the function a at r equals to, what did I pick? 1 is just the derivative of a at 1. Okay, so first of all you have to calculate the derivative. Remember that a was pi r squared. And just to emphasize, this is the derivative with respect to r. d by dr evaluated at r is equal to 1. So it's the derivative with respect to r. So the derivative is 2 pi r, and we have to evaluate it at r equals to 1. So we just get 2 pi times 1, which is 2 pi. So the rate of change is just 2 pi, at least when r is equal to 1. All right, let's try another example. Let's, in this one, let f of x equal to x to the 1/3. And let's just do the instantaneous rate of change, or as people normally say, just the rate of change. The rate of change of f at x equals to 8 is, again, it's the derivative, f prime at 8. That's all it is. Calculate the derivative, plug in 8. The variable here is x. You could have also have written it df dx, evaluated at x equals to 8, however you want to do it. So here, the derivative is 1/3 x, and then you subtract 1, so it's minus 2/3. That's the derivative, and we have to evaluate it at x equals to 8. So that means we just put in 8 there, so 1/3. That's a terrible 3. 1/3, 8 to the minus 2/3. And this, that's a fine answer, but it's also possible to simplify it a lot. So the trick is to realize that 8 is 2 cubed, 2, 4, 8, right? 2/3 power. And remember that exponents multiply, so the 3's cancel, and you get 2 to the minus 2. So that's 1/3 times a 4th, which is a 12th. And that's it. So rate of changes, just taking derivatives, nothing fancy.